A global enterprise ran a tenant audit last year. They found something most organizations never look for. 6,200 applications, 4,000 flows, 900 connectors, all inside a single default environment. The default environment is supposed to be a playground. It's where users experiment, where they build personal productivity apps. It's not where you run production. Yet that's exactly what happened. An entire shadow application platform, apps owned by employees who left years ago, flows triggering business-critical processes with no monitoring, data moving through integrations nobody documented, nobody approved, nobody owned. When I say nobody owned it, I mean literally. Most apps had an owner field pointing to a user ID from 2019. That person no longer worked there. Here's what matters. This wasn't a breach. This wasn't rogue developers. This was the natural outcome of treating a development platform like it's a productivity tool. That distinction matters. This episode explains why low-code adoption exploded. To understand how we got here, go back 10 years. IT backlogs everywhere hit a wall. Request queues sat at 12 to 18 months. You'd submit a project request and know you weren't getting an answer for over a year. Business units got tired of waiting, tired of IT saying, we'll get to you eventually. The market for professional developers was brutal. Supply couldn't keep pace with demand. Companies bid against each other for talent. A competent developer could write their own ticket.
Salaries climbed. Hiring freezes meant fewer people doing more work.
Low-code platforms came along with a specific promise: apps in weeks instead of months. No coding expertise required. Business users could build database applications using visual interfaces. No SQL, no programming languages. Drag and drop, click and configure. The narrative was compelling. Let citizen developers solve the backlog problem. Free up IT to focus on infrastructure. Let the business build what it actually needs instead of waiting months for IT to translate requirements. Executives loved the cost story. A citizen developer building apps in Power Apps doesn't cost a $150,000 salary, doesn't require 6 months of waiting, doesn't require formal requirements and project meetings. By 2026, citizen developers outnumbered professional developers 4-1. 4 business users building applications for every trained software engineer. The platforms made this effortless. Microsoft Power Platform integrated into Microsoft 365. You already had a Microsoft 365 license. Power Apps was included. Power Automate was included. You clicked buttons and built something that worked. Something that solved a real problem. Something that moved today instead of 2027. Here's the architectural mistake nobody discussed. Organizations believed low code meant less governance. Fewer rules, fewer policies, more speed, less bureaucracy. That's not what it meant. Low code actually means distributed governance. It means spreading development authority across the organization. It means thousands of people making architectural decisions who've never taken a software engineering course. It means building systems without the discipline that traditionally constrained those decisions. Speed without architecture creates a specific problem. Organizations discovered that within 3 to 5 years.
But we're getting ahead of ourselves.
The architectural misunderstanding. Most organizations treat Power Platform as a productivity tool, like Excel, like SharePoint, something you enable for the business and trust users to operate responsibly. That is not what Power Platform is. Architecturally, Power Platform is a distributed development environment embedded inside Microsoft 365. That distinction matters. That distinction explains everything that goes wrong. A productivity tool stores data, manages collaboration, lets users organize information. Excel is a productivity tool. SharePoint is a productivity tool. You can misconfigure them, you can leak data, but they are not fundamentally platforms for building applications. Power Platform is different. It is an application development platform. It has a runtime. It has a data layer. It has connectors that integrate external systems. It can trigger automations across your entire technology estate. It can move data between systems. It can make decisions and execute them automatically. Here is what it does not have: a compiler. No static type checking, no forced deployment pipeline, no code review, no version control requirement, no automated testing framework, no governance enforced by the platform itself. This is the architectural truth. Every citizen developer using Power Platform is effectively writing software. They are architecting databases. They are building business logic. They are integrating systems. They are making security decisions. They are implementing data flows that touch sensitive information. They are doing this without formal training, without architecture review, without the discipline that traditionally constrained these decisions in software engineering. Organizations deployed a development platform without development discipline. Then they told users to go build. What looks like citizen productivity is actually unmanaged application sprawl. The comparison matters. When you enable Excel, you are enabling a spreadsheet tool. Users can build bad spreadsheets. Users can create massive workbooks with broken formulas. You can lose data, but the blast radius is contained. It is a spreadsheet. The organization survives. When you enable Power Platform, you are enabling a development platform. Users can build bad applications. Users can create integrations that violate security policy. Users can move sensitive data where it should not go. Users can create automations that trigger uncontrollably. The organization does not just survive, it is now running mission-critical processes built by people who have never seen a design pattern. This is not a judgment about citizen developers. This is architecture. This is what happens when you distribute development authority without distributing development discipline. The platforms make this invisible. Power Apps makes it effortless to connect to a data source. You click, you drag, you drop, an app appears. It works, it solves a problem. The UI is clean, the interactions are smooth. You have no sense that you just built a database application with no normalization, no referential integrity, no access controls. The ease of construction is precisely why this matters. Organizations see speed and interpret it as simplicity. Speed in low-code is not simplicity. Speed is abstraction. The platform is hiding complexity, not eliminating it. It is hiding the fact that you are building software.
Here is what a citizen developer sees. I clicked buttons and built an app. This app lets my team organize their work.
This app saves time. This app works. Here is what an architect sees. This application has no documented data model. It has no owner. It has no documented business purpose. It has no retirement plan. It connects to 3 external systems with no audit trail. It stores credentials in the app's connection reference. It uses a personal cloud account for storage. It has no security review. It will fail silently when that person leaves. These are the same app, 2 different interpretations of the same reality. The architectural misunderstanding is treating the citizen developer's interpretation as complete. Organizations believe they have a productivity tool when they have deployed an unmanaged development platform. They believe they have empowered the business when they have distributed architectural responsibility across people without architectural training. This is where the problems begin.
Not because low code is bad,
but because architecture matters. The default environment disaster. Every Microsoft 365 tenant comes with a default environment. This environment exists for a reason. It is meant to be a sandbox. A place where users experiment, where they learn, where they build personal productivity apps without friction. Here is what actually happens. The default environment becomes the primary application platform. By default, every user in your tenant is an environment maker. That means they can create apps in the default environment. They can create flows. They can build without approval, without review, without anyone knowing it exists until something breaks. The data from tenant audits is consistent. 70 to 80% of all Power Platform artifacts, apps, flows, automations exist in the default environment, not in managed production environments, not in isolated team environments, not in controlled governed spaces, in the default environment. This reveals the reality most organizations avoid. They never implemented environment architecture at all. They enabled Power Platform. They told users to go build. They left the default environment open. And then they were surprised when the default environment contained thousands of applications. The surprise is the indicator that architecture did not happen. Let me describe what happened in that global enterprise we discussed. The audit found 6,200 applications, 4,000 flows, 900 connectors, all in the default environment. Think about that scale for a moment. That is not a mistake. That is not a few rogue developers. That is the outcome of an organization saying everyone can build without defining where, how, or under what conditions. When the audit team asked about those 6,000 applications, they discovered a pattern. First, 40 to 50% of the applications showed zero usage in the past year. They had been created, possibly used once, then abandoned. Yet they remained in the environment, connected to live data sources, retaining security permissions, creating permanent attack surface. Second, most applications had no documented owner. The owner field pointed to user IDs that no longer existed in the directory. Those people had left the company, retired, moved to different roles. The applications remained, orphaned, unmanaged, connected to systems they were never meant to touch. Third, the flows, thousands of them, were triggering automations across the entire technology estate. Some updated SharePoint sites, some sent emails, some moved data between systems. Many had no documentation about their purpose. Most had no monitoring. If a flow failed silently, nobody knew. If a flow triggered unexpectedly, nobody understood why.
Fourth, the connectors revealed the data story.
900 different connector instances, meaning 900 different integrations to external systems and services. Some of those connectors used personal cloud accounts. Someone's Dropbox, someone's OneDrive, someone's personal Google Drive. Data was flowing to personal storage because the app needed somewhere to put files, and the easiest path was the user's personal cloud account. Let me be precise about what this means architecturally. An unmanaged shadow application platform had emerged inside the tenant, not unauthorized. Power Platform was approved, but the applications themselves had no governance, no lifecycle management, no ownership accountability, no documented business purpose. The organization was running production workflows inside an environment designed for personal experimentation. When you ask why this happened, the answer is simple. The default environment is frictionless. Creating an app in the default environment takes minutes. No approval, no environment request, no security review, no wait. Just click and build. When you ask why it was never discovered, the answer is also simple. Default environment usage was invisible. It does not appear on most governance dashboards. It does not trigger alerts. It just grows, quietly, until an audit reveals thousands of applications that nobody knew existed. This is the default environment disaster. Not that the environment exists, environments are necessary, but that organizations deployed a development platform, left the development environment completely open, and then acted surprised when developers filled it with applications. The default environment is not the real problem. It is the symptom of an organization that enabled a development platform without implementing the governance that development platforms require. But this is just one failure pattern. The real problem runs deeper. The connector governance gap. Power Platform connectors are the integration layer. They are how applications reach beyond the platform and touch the rest of your technology estate. A connector is a bridge. It connects Power Apps to SharePoint, connects Power Automate to Dynamics, connects applications to external services, connects your internal systems to personal cloud accounts. And this is where the real damage happens. The architectural problem is structural. Connectors are approved at the tenant level, not enforced at the application level. When an administrator approves a connector, that connector becomes available to every application in the environment, every flow, every app, every automation. There is no concept of this connector is approved for this specific application or this connector can only access this specific data. The approval is binary, approved or blocked. Once approved, it is available everywhere. Here is the vulnerability. Overly permissive connector policies create data leakage pathways. A single poorly configured flow can expose sensitive data across organizational boundaries. Consider what happened at a financial services organization. They enabled Power Platform. They wanted citizen developers building workflow automations. They wanted to accelerate digital transformation. They approved connectors for the business. SharePoint connector, Dynamics connector, OneDrive connector, Outlook connector, standard business services. A few months later, an architect noticed something unusual in the audit logs. Power Apps were moving SharePoint data into personal Dropbox accounts. Not a Dropbox managed by the company, personal Dropbox accounts, someone's individual cloud storage. When they traced the flow, the path was simple. An application was reading confidential data from a secure SharePoint library. The SharePoint connector accessed the data. The Dropbox connector moved the data to personal storage. No security warning, no policy violation detected, no audit alert, the connectors were approved. The user had the right to access SharePoint. The Dropbox connector moved the files. From the platform's perspective, everything was legitimate. From a compliance perspective, it was a near catastrophe. Sensitive financial data was sitting in someone's personal cloud account, not encrypted by the company, not secured by corporate DLP policies, not subject to corporate retention policies, accessible by whatever device that person used, backed up by whatever backup service Dropbox uses, potentially accessible to anyone who compromises that personal account. The root cause was not user malice. The person building the flow was trying to solve a real problem. They needed to get data somewhere. They needed to automate a process. They had access to a SharePoint library. They had a personal Dropbox account. They connected them. The system allowed it. So they did it. The organization believed Power Platform was secure by default. It is not. Security in Power Platform is permissive by default. If a connector is approved and a user has permission, the data moves. Here is the architectural problem. Data loss prevention policies exist. DLP in Power Platform can restrict connector combinations. You can create rules that say SharePoint connector cannot be used in the same flow as personal cloud storage connectors. You can enforce this at the environment level. You can audit violations, but DLP policies are not automatically applied. They require explicit configuration. They require an organization to think through which connector combinations are risky. They require someone to define data sensitivity levels and map those to connector restrictions. Most organizations never do this. They approve connectors and assume the user will make responsible choices. This is not architecture. This is hope. The consequence is straightforward. Sensitive data moves where it should not go, sometimes to personal accounts, sometimes to external services, sometimes to systems without encryption, sometimes in violation of compliance requirements the organization never documented in the first place. One near breach becomes multiple breaches. Multiple breaches become a pattern becomes a compliance violation. This connector governance gap is the infrastructure underneath the default environment disaster. Both reveal the same underlying truth. Power Platform distributes capability without distributing the governance that capability requires. But the data movement problem is actually secondary to what comes next, because the real sprawl happens in the automations. The flow explosion problem. Power Automate flows are automation pipelines. They trigger on events, they execute business logic, they integrate systems. A flow watches for a specific condition, a file is created, an email arrives, a record is modified, and then it acts. It sends a notification, it creates a record in another system, it moves data, it makes a decision, and executes the consequence. Flows are easy to build, extremely easy. You specify a trigger, you add actions, you save. The flow runs. No deployment process, no version control, no approval gate. A user with the right permissions can build a flow in 10 minutes that touches your entire enterprise architecture. This is where scale becomes a problem. Large tenants accumulate thousands of flows, not hundreds, thousands. A retail organization we mentioned, they ran an audit and found 11,000 Power Automate flows. 11,000 automations running across their technology estate with no centralized visibility, no lifecycle management, no documented purpose, most triggered every few minutes. Think about that scale, 11,000 pipelines executing continuously, each one making decisions, each one integrating systems, each one potentially failing in ways nobody anticipated. The consequence is straightforward, API throttling. The systems these flows connect to have rate limits. SharePoint has throttling, Dynamics has throttling, Exchange has throttling. When 11,000 flows trigger simultaneously, they hit those limits. Requests queue, requests fail. The business experiences degraded performance during peak hours because automations created years ago are now running at scale against systems they were never designed to touch. Licensing overages follow. Power Platform licensing is metered. Some flows consume premium connector licenses. Some flows consume API calls against your tenant quota. When you have 11,000 flows, many redundant, many abandoned, many triggering far more frequently than necessary, the licensing bill becomes unpredictable. Organizations often do not realize flow volume until costs start escalating. Here is the architectural issue. Flows are invisible to governance until they fail. A flow runs silently. It executes its automation. If it succeeds, nobody notices. If it fails, it might trigger an alert. It might fail silently. It might retry automatically. It might leave data in an inconsistent state. But the flow itself, its existence, its purpose, its impact remains invisible until something breaks. The documentation gap is profound. In the retail organization audit, most of those 11,000 flows had no owner. No documented business purpose, no lifecycle policy, no retirement date, no success criteria, just flows that existed and executed.
When someone asked, "Why does this flow exist?" the answer was often unknown.
The person who created it had left the company. The business need it addressed had changed. The system it integrated with had been replaced. But the flow remained, running, consuming API quota, potentially moving data or triggering actions based on logic nobody remembered. This is technical debt manifesting as operational drag. The organization paid for every flow through licensing costs. They paid for API calls the flows consumed. They paid in system load. They paid in performance degradation. And they received no visibility into what that payment purchased. The hidden cost is that organizations often do not realize flow volume until performance degrades or licensing costs spike. There is no forcing function, no alert that says you now have 5,000 flows. No warning that says this flow has been dormant for 6 months and should be retired. No governance dashboard showing which flows are business critical and which are abandoned experiments. Flows accumulate silently until they create a problem too large to ignore. This is the flow explosion problem. Not that flows are bad. Automation is valuable. Flows that orchestrate business processes correctly save labor and reduce error. But flows without lifecycle management, without documented purpose, without ownership accountability, without retirement plans, those flows become hidden operational debt. The sprawl is invisible until it is catastrophic. The cost is invisible until it is unaffordable. The impact is invisible until systems degrade. And this pattern, easy to build, invisible until failure, costly to remediate, creates a specific financial consequence that organizations eventually discover. The licensing surprise. Organizations discover the true cost of unmanaged Power Platform when the bill arrives. Power Platform licensing is tiered. There are per-user licenses, per-app licenses. Premium connectors carry additional cost. Dataverse storage is metered, you pay per gigabyte. Environments beyond a certain number require capacity add-ons. The pricing model is designed to scale with usage. What organizations do not anticipate is how quickly that usage scales when governance does not exist. A multinational company made a strategic decision. They would enable Power Platform for citizen development. They would democratize application building. They would accelerate digital transformation. They would reduce IT backlogs. All of this sounded correct. All of it aligned with the market narrative around low-code platforms. Within 2 years, Power Platform became one of the top 5 SaaS expenses in the organization's IT budget. Here's what happened. Dataverse storage exploded. Power Apps need a database. That database is Dataverse. Every app that stores data uses Dataverse capacity. When you have thousands of applications, many storing duplicate data because there is no data architecture, Dataverse usage climbs exponentially. The organization hit storage limits they had not anticipated. They purchased additional capacity, then hit those limits again. Premium connector usage skyrocketed. Standard connectors, SharePoint, Teams, Outlook are included. Premium connectors, the ones that connect to specialized systems, external services, API gateways, require additional licensing. The organization had approved premium connectors broadly. Flows that used premium connectors scaled. Suddenly, the organization needed far more premium connector licenses than they had budgeted for. Environment sprawl required additional licensing tiers. The organization realized they needed more than the default environments. They created team environments. They created project-specific environments. They created sandbox environments. Each environment beyond the initial allocation requires a capacity add-on. The licensing bill climbed again. The organization could not answer a basic question. Which of these costs were justified? Which applications justified their dataverse storage? The organization could not tell. Most applications had no documented business value, no success metrics, no measurement of whether the app was solving the problem it was supposed to solve, which premium connectors were delivering value. The organization could not tell. They knew premium connectors were being used. They did not know which flows used them or why those flows were necessary, which environments were essential. The organization could not tell. Some environments were legacy, created for pilots that had concluded. Some environments were test environments that had become production. Some environments were abandoned after projects completed but never deleted. The visibility gap was total. The organization had perfect financial visibility. They could see the bill. They had zero operational visibility. They could not map that bill to business value. The financial impact was approximately $2 million in unexpected licensing costs over 2 years. Not catastrophic in the context of an enterprise IT budget. Significant enough to require explanation. Impossible to justify because the organization had no data connecting costs to outcomes. Here is the architectural lesson. Without lifecycle management, you are paying for assets that do not deliver value. The organization was paying per gigabyte for dataverse storage consumed by abandoned applications. They were paying for premium connector licenses consumed by flows nobody remembered creating. They were paying for environments created for projects that had concluded years earlier. The licensing surprise is not actually about licensing. It is about the invisible consequence of unmanaged sprawl. When you deploy a platform without governance, when you allow thousands of applications to accumulate without lifecycle management, when you never retire anything because retirement requires effort, you eventually discover that you are paying for a massive amount of unused capacity. The bill arrives. The organization realizes the cost.
They ask which applications justify that cost.
Nobody can answer because nobody has been tracking which applications exist, much less which ones are essential. This is when organizations typically make a decision. They either invest in serious governance to clean up the mess, or they accept that this is the cost of enabling citizen development. Most organizations choose neither immediately. They freeze spending, they demand ROI justification for new applications, they hire a consultant, they launch a cleanup project, and then they discover that cleaning up the mess is far harder than preventing the mess would have been. The zombie app problem. Here's a pattern that appears in every tenant audit. 30 to 50% of applications show zero usage after creation. Zero, not low usage, not declining usage, no usage at all.
For months, for years, the application was built, deployed, then abandoned.
But it was never retired. This is the zombie app problem. Applications that exist but serve no function.
Applications that consume resources but deliver no value.
Applications that persist in your environment connected to live data, retaining security permissions, creating permanent attack surface. Why do they persist? The answer is architectural. Power Platform has no forced deprecation mechanism. There is no automatic retirement policy. There is no system that says this application has had zero usage for 90 days. It will be deactivated. There is no enforcement that requires ownership. There is no policy that forces a business justification. The application simply remains connected, accessible, running. Zombie apps exist for predictable reasons. A team builds an application to solve a specific problem. The problem gets solved, the business need changes. The person who built the application leaves the company. The project concludes, the application becomes irrelevant, but it is never formally retired because retirement requires administrative action. Retirement requires someone to decide the application is no longer needed. Retirement requires someone to take responsibility for deactivation. In the absence of a formal lifecycle policy, retirement does not happen. The application remains in the environment, accessible, connected to data sources, retaining the permissions it was created with, a permanently dormant asset. The risk is straightforward. A zombie application remains connected to live data. If that application is ever reactivated because a user remembers it exists, or because someone restores it, or because an automated process re-enables it, it connects to whatever data sources it was originally configured to reach. Those data sources may have changed in the years since the application was abandoned. The application may now have permission to access data it was never intended to touch. Zombie applications retain security permissions. The application was created with specific access rights. Those permissions remain if the application is inadvertently activated or if someone modifies it, those permissions are still in place. A security review may have been performed when the application was created. No review occurred in the years it was dormant. The security posture of the surrounding systems may have changed. The application's permissions may no longer be appropriate. This creates long-term attack surface. Every zombie application is a potential vector for compromise. An attacker who gains access to the application gains the permissions that application was granted. An attacker who understands what data the application can reach gains visibility into sensitive systems. An attacker who activates a dormant application may trigger automations or data movements that have not been validated in years. The operational cost is hidden. It must maintain zombie applications, must patch them if they are part of a managed solution, must monitor them for compliance audits, must answer questions about what they do and why they exist, must eventually decide whether to keep them or delete them. All of this effort is consumed by applications delivering zero business value. The architectural failure is that Power Platform treats application lifecycle as optional. An application created in Power Apps exists forever unless explicitly deleted. There is no concept of deprecation, no concept of automatic retirement based on usage metrics, no concept of mandatory review after a period of inactivity. The platform allows applications to accumulate indefinitely. This is fundamentally different from enterprise software systems. Traditional application portfolios have lifecycle management. Applications are flagged for review. Applications showing no usage trigger notifications to stakeholders. Applications are retired after they reach end of life. The organization actively manages what runs and what does not. Power Platform inverts this. Applications are created and persist forever unless actively removed. The organization must continuously expend effort to clean up applications nobody uses. The zombie app problem is the consequence of treating Power Platform as a tool rather than a platform. A tool you use and discard. A platform you must actively manage for its lifetime. These individual failures, the default environment sprawl, the connector governance gap, the flow explosion, the licensing surprises, the zombie applications, are not isolated problems. They are symptoms of a deeper architectural issue. An organization has distributed development authority without distributing the governance that development requires. It is enabling unlimited application creation without any mechanism for application deprecation. It is building a platform on the assumption that users will self-regulate their behavior. That assumption is not architecture. That is hope. And hope does not scale. When these patterns compound, when they interact with each other, the system reaches a critical threshold. An organization with thousands of applications, thousands of flows, hundreds of zombie assets, all consuming licensing costs, all creating security surface, all requiring governance effort, reaches a point where the platform becomes unmanageable. Shadow IT 2.0. Shadow IT has a traditional definition. Unauthorized SaaS tools. Dropbox when IT standardized on OneDrive. Slack when the organization approved Teams. Trello when IT set to use Project Online. Salesforce when the company mandated Dynamics. These were the classic Shadow IT violations. Employees used tools IT did not approve because those tools solved problems faster than approved solutions. The security and compliance teams fought Shadow IT for decades. Block the tool. Disable the account. Write policy prohibiting unsanctioned applications. Shadow IT persisted because the underlying motivation was real. Users had genuine problems. Approved solutions were too slow, too expensive, too rigid. So they used unauthorized tools and hoped nobody noticed. By 2024, Shadow IT accounted for 30 to 40% of enterprise IT spending. Not a rounding error, 30 to 40% of the entire IT budget was consumed by tools and services nobody formally approved. That is the scale of the problem. Power Platform creates a new variant of Shadow IT. The platform is authorized, the governance is not. Here is the distinction that matters. Shadow IT traditionally meant unauthorized tools. Shadow IT 2.0 means an authorized platform used without authorization. The platform is approved. Power Platform is part of Microsoft 365. The organization enabled it. Users can build in it. But the applications themselves, the ways the platform is used, the integrations users create, the data they move, those operate without governance. This is authorized Shadow IT. The platform is legitimate. The usage is uncontrolled. Consider what happens when a user creates a Power Apps environment, not the default environment, a dedicated personal environment they request. The organization approves the request because Power Platform is approved. The user now has their own development environment, their own Dataverse database, their own connector integrations, their own automation rules. A single free trial workspace generates roughly 3 API tokens. 2 unmanaged credentials stored somewhere, possibly in the app, possibly in a notes application, possibly written on a sticky note. 1 OAuth grant that bypasses multi-factor authentication because the grant was created before MFA policies existed and nobody reviewed the grant afterward. An organization with 291 hidden Power Platform workspaces, not in the tenant's official inventory but discoverable if you know where to look, has 1,700 secrets floating around in unmanaged environments. Credentials, API tokens, OAuth grants, all outside normal credential management, all potentially accessible to compromised users, all potentially exposed if someone backs up the application and sends it to the wrong person. The governance gap is profound. Organizations believe Power Platform is governed because it is inside Microsoft 365. It is subject to security policies. It is covered by compliance frameworks. It is IT approved. None of this is false. Power Platform is governed at the platform level, but the individual applications and integrations users create inside the platform are not necessarily governed. Default environment access means most users are effectively developers. They can create applications, integrations, automations. They can store secrets. They can move data. They can connect external services. All of this is possible without security review, without compliance assessment, without IT oversight, without anyone knowing it is happening. The consequence is that Shadow It evolved. It did not disappear. It transformed. Shadow It is no longer unauthorized SaaS tool that IT banned. Shadow It is now authorized platform, unauthorized usage. The organization approved Power Platform. Users are using Power Platform to do things the organization never intended. They are creating integrations the organization never assessed. They are moving data in patterns nobody documented. They are storing credentials in patterns that violate security policy. This is Shadow IT 2.0. The platform is legitimate. The governance is missing. Organizations respond by treating Power Platform like a productivity tool. They believe that because Power Platform is inside Microsoft 365, the security of Microsoft 365 covers it. That DLP policy is protected. That conditional access controls it. That audit logs capture what matters. None of these assumptions are wrong, but they are incomplete because users are building applications and applications require application-level governance. Security at the platform level does not prevent poorly designed applications. DLP at the tenant level does not prevent individual flows from moving data inappropriately. Conditional access controls user identity, not what an automated process does after authenticating. Shadow IT 2.0 is the gap between platform-level governance and application-level governance. The organization governs the platform. Users build applications. The applications operate in the gap between those two layers, visible to neither. Technical debt in low code. Technical debt is a financial metaphor Ward Cunningham introduced to describe the future costs of shortcuts in software development. You prioritize speed today. You cut corners. You defer design work. You skip documentation. You build something that works now. In exchange, you incur a debt. That debt accrues interest.
The interest is paid in maintenance costs.
The interest is paid in bugs that multiply. The interest is paid in the effort required to change things that were never designed to change. In traditional software development, technical debt manifests as code debt. Poorly written functions, missing test coverage, brittle architectures, deprecated libraries. When you have code debt, developers see it. The code is right there. The complexity is visible. A developer reading a function with poor structure recognizes the debt immediately. Compiler warnings surface the problem. Static analysis tools identify code smell. Debt is visible. Low-code technical debt is different. It is implementation debt, not code debt. Poor solution structures, inconsistent patterns, missing documentation, data models that were never normalized, integrations that were never architected, automations that were never designed to work at scale. The debt is invisible because the code is invisible. The platform hides the implementation. Users see the app, they see it works. They have no sense, they just accumulated years of maintenance burden. Here's what this looks like in practice. An application works beautifully on day one. A citizen developer built it in 2 weeks. The business user who requested it is delighted. The app solves the problem. It is performant, it is clean, it does the job. By day 90, the app still works. By day 365, the app is a fragile house of cards. Adding a single new feature requires understanding a tangle of undocumented logic. Performance is degrading because the database was never normalized. The data model was never reviewed.
The app stores duplicate data across 3 different Dataverse tables because the original builder did not understand relational design.
Changing anything risks breaking something else. The organization faces a choice: maintain the fragile application or rewrite it. Most organizations choose rewrite. They lose years of accumulated functionality. They lose the tribal knowledge about what the application actually does. They rebuild from scratch. And the rebuilt application, absent proper governance, follows the same pattern. Works beautifully at first, accumulates debt silently, becomes unmaintainable within 2 years. Here is the compounding effect that most organizations do not anticipate. The first application accumulates debt. The maintenance burden grows. The organization does not notice because the application still works. The second application is built. Same pattern. The third application, the fourth. By the 10th application, the organization now has 10 fragile systems, each accumulating maintenance burden independently, each requiring exponential effort to modify, each becoming more expensive to maintain than to replace. The real pattern organizations observe is that critical failures happen after 2 to 3 years of unmanaged Power Platform growth, not immediately. The first 6 months are glorious. The platform works, applications are built in weeks, users love the speed, leadership loves the velocity. Then gradually, systems that worked perfectly start requiring more and more effort to change. Features that should take a week now take a month because understanding the existing application requires reverse engineering undocumented logic. The architectural issue is that low-code platforms hide the debt. In traditional development, a compiler forces you to confront problems. A type system catches errors before runtime. Static analysis identifies complexity. Code reviews surface issues. None of these mechanisms exist in low-code. An application compiles successfully because there is no compiler. The platform does not enforce naming conventions. The platform does not require documentation. The platform does not flag complexity. An application can be a complete architectural disaster and still run without warnings. This is why the debt is invisible. The system works. There is no signal that debt is accumulating. No compilation errors, no performance warnings, no architectural alerts. The application functions, so the organization assumes the application is healthy. Then 2 years later, the organization discovers that maintaining the application costs more than rebuilding it, and the knowledge required to rebuild it has walked out the door with departed staff members. Technical debt in low code is perhaps the most pernicious form of technical debt because it accrues silently, invisibly, until the organization discovers it is no longer paying for maintenance. The organization is paying for architectural rewrite. This debt accumulates because governance models systematically fail to prevent it. Most organizations implement governance that is reactive, not preventive. They observe problems and respond. By that point, the debt is already embedded in the system. Why standard governance models fail? Most organizations understand that Power Platform requires governance. They recognize the problems we have described. They respond by implementing what the market calls a center of excellence. A center of excellence is a governance team, typically staffed by a Power Platform admin, a security lead, and a few advocates from the business. The COE publishes policies. The COE maintains a governance dashboard. The COE tracks application inventory. The COE runs training programs. The COE tries to establish standards and encourage compliance. This is reasonable. The COE provides real value. Organizations with mature centers of excellence achieve meaningful improvements in visibility. They know how many applications exist. They know who owns them. They can see which flows are consuming API quota. They can track Dataverse storage consumption. They can identify zombie applications. They can measure adoption velocity. All of this is useful. It is observability, visibility into what is happening. But here is the critical distinction that most organizations miss. Observability is not enforcement. A center of excellence is an observability tool. It sees the problem. It does not prevent the problem. Here is the failure pattern that repeats across enterprises. An organization implements a mature COE. They build governance dashboards. They create policies. They define lifecycle management processes. They train makers. They do everything right. And then they discover that sprawl continues. Applications still accumulate, flows still proliferate, the default environment still fills with unmanaged applications. Why? Because the COE has no authority to prevent these things. The COE can identify a zombie application. The COE cannot automatically retire it. The COE can recommend environment strategy. The COE cannot force makers to use the strategy. The COE can ask for application documentation. The COE cannot block an undocumented application from running. COE recommendations are advisory. They lack enforcement. An organization with a mature COE still experiences sprawl because COE governance assumes compliance. COE assumes that if you tell people the right way to behave, people will behave that way. This assumption fails consistently. Consider environment strategy. Most organizations understand that they should segment environments, default for personal productivity, team environments for shared solutions, production environments for business-critical applications, clean separation, clear boundaries, good architecture. Then they implement it. They create the environments. They publish the strategy. They tell makers where to build. And they leave the default environment accessible. Because restricting the default environment requires effort, requires updating environment roles, requires communicating to users that the default environment is no longer available for shared applications, requires managing the exceptions and requests that will inevitably follow. So the default environment remains open, accessible, frictionless. And makers, when faced with the choice between following the strategy and taking the frictionless path, choose friction avoidance. They build in the default environment. The environment strategy collapses in practice because the organization never enforced it architecturally. DLP policies follow the same pattern. Organizations create DLP rules. No high-risk connectors in the same flow as sensitive data connectors. No personal cloud storage connectors moving SharePoint data. Good rules, reasonable restrictions. Then the organization implements them and discovers that enforcement is inconsistent. DLP policies apply in some environments and not others. They apply to new flows but not to existing flows. A maker violates a DLP rule and the policy blocks the flow, so the maker requests an exception. The COE reviews the exception. The exception is granted. The DLP policy is circumvented. The organization now has a DLP policy that is technically enforced but practically circumvented. The policy exists, but exceptions have undermined the policy. One policy exception becomes 2, becomes 10. The policy that was supposed to prevent data leakage is now advisory because exceptions made it unenforceable. ALM pipelines follow the same pattern. Organizations understand that production applications should use managed solutions and deployment pipelines. Good practice. So they build the pipelines, they configure dev test prod environments, they set up the automation, they tell makers use the pipeline. And they discover that citizen developers think the pipeline is too complex, too many steps, too much overhead. The pipeline process feels like bureaucracy. So makers skip the pipeline. They export the solution manually. They import it directly into production. They bypass the governance process. The organization now has a pipeline that exists but is unused because the makers chose to bypass it. The governance infrastructure is there. The governance is not enforced. The root cause is architectural. These governance models all assume that compliance is a choice. Organizations assume that if you provide the right information, publish the right policies, and build the right tools, people will comply voluntarily. But compliance is not a choice in architecture. Architecture enforces outcomes. A firewall does not ask packets to stay out. It blocks them. A database constraint does not recommend referential integrity. It enforces it. A compiler does not suggest type safety. It prevents non-type safe code from running. When you move from governance to architecture, you move from advisory to enforcement. You move from "we recommend this" to "the system prevents the alternative." This is the distinction that matters. The governance reality check. Organizations need to reframe Power Platform, not as a productivity layer, not as a democratization tool, not as something you enable for the business and hope users operate responsibly. Power Platform is a development platform. That reframing changes everything. A development platform requires architecture discipline. You would not allow developers to deploy code to production without version control. You would not allow them to skip testing. You would not allow them to bypass code review. You would not allow them to deploy directly to production whenever they felt like it. These are not suggestions. These are fundamentals of responsible software engineering. Yet Power Platform allows exactly this. A citizen developer can build an application in the default environment and move it to production without version control, without testing requirement, without approval gates, without documentation. The system does not prevent this. The system enables it. Here is the uncomfortable truth that most organizations avoid. Citizen developers are software engineers. They are architecting databases. They are building business logic. They are integrating systems. They are making security decisions. They are implementing data flows. They are doing software engineering work. Treating them as users is an architectural error. When an organization enables Power Platform, they enable a development platform. When they leave the default environment open, they enable unmanaged development. When they do not enforce environment strategy, they enable development in uncontrolled spaces. When they do not require managed solutions and pipelines, they enable deployment without governance. When they do not document application ownership and lifecycle, they enable unaccountable software engineering. The organization then acts surprised when the platform behaves like what it is: an unmanaged development environment. The consequence is that organizations apply user-level governance to platform-level problems. They focus on access control. Who can create environments? Who can create flows? Who can access data? These are important questions, but they are not sufficient. They are necessary conditions for governance. They are not sufficient conditions. A user with appropriate access can still build a poorly designed application. A user with appropriate access can still create an integration that violates security policy. A user with appropriate access can still design a data model that was never meant to exist. A user with appropriate access can still move data in patterns that create compliance violations. User-level governance controls identity and access. Platform-level governance controls what the platform allows. Application-level governance controls how applications are designed, reviewed, deployed, and maintained. Most organizations implement user-level governance. Some implement platform-level governance. Few implement application-level governance. Application-level governance is what is missing. This is architectural governance. Enforcing design patterns, preventing lock-in through standardized integrations, managing dependencies through documented relationships, requiring documentation of business purpose, requiring security reviews before deployment, requiring performance assessment before release, requiring ownership accountability, requiring lifecycle management, standard IT governance, access control, compliance, monitoring is necessary. It is not sufficient.
It handles the outer boundary.
It determines who can access what. It ensures audit trails. It captures what happened. But it does not prevent a poorly designed application from being deployed. It does not prevent a fragile data model from accumulating technical debt. It does not prevent undocumented logic from becoming unmaintainable. It does not prevent citizen developers from making architectural mistakes because they lack training in architectural thinking. What is needed is a reframing. Organizations must treat Power Platform as what it is, a development platform that requires development discipline. This reframing is uncomfortable because it means admitting that citizen development is not frictionless. Citizen developers cannot simply build. They must build with discipline. They must document business purpose. They must undergo security review. They must design for maintainability. They must follow patterns established by the organization. This sounds like bureaucracy to many citizen developers. They enabled Power Platform because they wanted speed. They wanted to avoid the friction of traditional software development. Adding governance back into the process feels like they have lost the benefit of the platform. This is the fundamental tension in Power Platform governance. The platform promises speed. The architecture requires discipline. Speed and discipline are not compatible without structure that makes discipline efficient. The organizations that succeed are the ones that accept this tension and resolve it architecturally. They create governance processes that are lightweight but enforced. They create approval gates that are fast but meaningful. They create standards that are restrictive but reasonable. They create frameworks that enable rapid development without sacrificing architectural discipline. This is not easy. This requires serious governance infrastructure. This requires a center of excellence with real authority. This requires enforcement mechanisms. This requires training. This requires a fundamental reframing of what Power Platform is and what it requires. But it is the only path to sustainable Power Platform architecture. Environment architecture strategy. Proper environment segmentation treats Power Platform as what it actually is, a tiered development platform, not a productivity tool, not a monolithic system, a tiered platform where different classes of applications operate under different governance rules. This tiering is the foundation of sustainable Power Platform architecture. Without it, everything collapses into the default environment disaster we described. With it, you create clear boundaries that separate experimental work from production impact, personal productivity from enterprise critical systems. The model has 3 tiers. Each tier serves a specific purpose. Each tier has different permissions, different connector policies, different lifecycle rules. Tier 1 is personal productivity. This is the default environment. This tier exists for individuals to experiment, to learn the platform, to build personal workflow automations, to try ideas without impacting anyone else. The default environment is restricted. No production data, no business-critical integrations, no shared applications. A personal sandbox where anyone can build, knowing that the blast radius is limited to themselves. Access to Tier 1 is open. Everyone has maker permissions in the default environment. This is intentional. The goal is to reduce friction for experimentation. Users should be able to try Power Platform without asking permission, without waiting for approval, without explaining to IT what they are building. Connector policy in Tier 1 is restrictive. Standard business connectors are available. SharePoint, Teams, Outlook. Personal cloud storage connectors are restricted. External API connectors are restricted. Anything that creates risk of moving sensitive data outside the organization is blocked. The default environment is for learning and personal automation. It is not for integrating critical systems. Tier 2 is team solutions, dedicated environments for departmental applications, for shared workflows where a team collaborates on a solution. These environments are not personal, they are shared. They require governance. Teams that want to build shared applications request a Tier 2 environment. The request includes business justification. What problem does this team solve? How many users will use the application?
What data does it access?
The organization approves Tier 2 environments based on this justification. Once approved, the environment is created with specific governance rules. These environments allow standard connectors. They allow premium connectors if justified. They allow shared data stores in Dataverse. They allow multiple makers to collaborate on solutions. The connectivity is broader than Tier 1 because the scope is broader. The impact is organizational, not personal. Tier 2 environments have lifecycle management. Applications in these environments have documented owners. They have business purposes. They have success metrics. They have documented retention policies. Applications that are no longer used are retired, not kept as zombies, actually deactivated and removed from the environment. Tier 3 is enterprise applications. Production environments. These environments are restricted. Creating an application in a Tier 3 environment requires formal approval. It requires architecture review. It requires security assessment. It requires documented ownership. It requires a managed solution. It requires deployment through a pipeline. It requires testing in a dedicated test environment before production release. Service accounts own Tier 3 applications, not individual users. Service accounts. This prevents orphaned applications when employees leave. This prevents applications from becoming personal assets. This ensures continuity. The service account is the permanent owner. Individual makers work within the framework, but the service account owns the asset. Connector policy in Tier 3 is strict. Only approved connectors, only connections authenticated with service accounts, only data flows that have been reviewed and documented. Premium connectors in production require explicit justification. External APIs in production require security review. Tier 3 is not experimental. It is not where you try things. It is where you deploy things that matter. Here is the critical implementation detail. Environment admins enforce this tiering by controlling who can create applications in each tier. Tier 1 is open to everyone. Tier 2 is open to teams with approved environments. Tier 3 is restricted to approved deployments through pipelines. The platform itself prevents inappropriate usage. Tier 1 makers cannot create applications in Tier 3. Tier 2 teams cannot bypass the pipeline for production deployments. The common failure is structural. Organizations create this environment architecture. They define the tiers, they publish the policies, they build the infrastructure. Then they leave the default environment open for production applications. They leave the governance recommendations as advisory rather than enforced. They do not restrict Tier 1 access to non-production applications. They do not enforce Tier 3 pipeline requirements. When this happens, the entire architecture collapses. The default environment again becomes the production platform. The tiering provides visibility without preventing sprawl. The governance looks good on paper. The architecture fails in practice. Proper environment architecture is necessary. It is not sufficient. You also need deployment discipline. You need ALM enforcement. You need to make the pipeline mandatory, not optional. ALM pipeline enforcement. ALM stands for Application Lifecycle Management. It is a framework that treats applications as managed assets. Assets with a life cycle, assets that move through distinct stages, development, testing, production. Each stage has specific requirements. Each stage has different governance rules. In traditional software development, ALM is enforced. You do not deploy code directly to production. Code goes through development environments. It goes through test environments. It goes through staging. At each stage, specific gates are enforced. Code review, automated testing, performance validation, security scanning. Only after passing all gates does the code move forward. This process is not optional.
It is enforced by version control systems,
By deployment automation, by infrastructure as code policies that prevent direct production changes. Power Platform allows direct deployment without any of this discipline. A citizen developer can build an application in the default environment and move it to production without version control, without testing, without approval, without documentation. The platform does not prevent this. The platform enables it. ALM pipeline enforcement changes this. It makes the development lifecycle mandatory. It creates gates that cannot be bypassed. Here is how it works. Production applications must use managed solutions, not unmanaged solutions. Managed solutions. This distinction matters. Managed solutions have version history. They support rollback. They support patches. Unmanaged solutions are development artifacts. They are meant for experimentation, not production. A citizen developer in a development environment creates an application. They build the functionality. They add the business logic. They test locally. When they are ready, they package the application into an unmanaged solution. They export that solution. The solution file goes into a Git repository. Now the application has version control. The export is tracked. Changes are documented. From Git, an automated pipeline picks up the solution. The pipeline runs automated tests. It validates that the solution is properly structured. It checks for common errors. It runs security scanning. If tests pass, the pipeline promotes the solution to a test environment. In test, real users validate the application. They confirm it works as intended. They identify issues. Issues go back to the developer. The developer makes changes. The updated solution goes back through the pipeline. When testing is complete and the application is approved, the pipeline imports the solution into production as a managed solution. This managed solution becomes the production version. It has version history. If something goes wrong, the organization can roll back to the previous version. The pipeline enforces that every production change is traceable. Every change has a record. Every change can be reversed. This is ALM enforcement. The pipeline is mandatory. There is no alternative path. Citizen developers cannot bypass the pipeline by importing solutions directly, cannot skip testing by moving to production manually, cannot deploy without approval because the pipeline enforces approval gates. The pipeline is not a recommendation. The pipeline is the only way production deployments happen. Here's the trade-off this creates. ALM pipelines introduce process overhead. They reduce the instant gratification of Power Platform development. A citizen developer cannot make a change and see it in production immediately. The change must go through the pipeline. It must pass testing. It must be approved. This takes time. It introduces friction. Citizen developers who built applications in 2 weeks suddenly find that deployment takes 2 more weeks. The business users who loved the speed of Power Platform suddenly face delays. The entire value proposition of low-code development, rapid iteration, quick time to value, appears to be lost. This is where organizations often fail. They implement pipelines. Citizen developers complain about the friction. The organization decides the friction is too high. They create exceptions. They allow manual deployments for certain applications. They skip testing for low-risk changes. The pipeline gradually becomes optional. Exceptions accumulate. The pipeline collapses into advisory governance. Organizations that succeed treat ALM pipeline enforcement as non-negotiable. Yes, the pipeline adds process. Yes, it reduces instant gratification. That is the point. Production applications should not be deployed instantly. They should be tested. They should be reviewed. They should be managed. The friction is not a bug. The friction is the feature. The frame matters. If you frame the pipeline as bureaucracy that slows development, developers will bypass it. If you frame the pipeline as a safety net that prevents production failures, enables rollback, and maintains audit trails, developers accept it. the pipeline becomes not a restriction. It becomes responsible engineering practice. ALM pipeline enforcement requires this mindset shift. Citizen developers must understand that production is not a testing ground. Production is where users work. Production is where data lives. Production is where the organization operates. Deploying to production without discipline risks production failures, risks data loss, risks security breaches. The pipeline is how you prevent these outcomes. Connector governance segmentation. ALM pipelines enforce the deployment process. They ensure that applications move through development, testing, and production with appropriate gates at each stage. But pipelines alone do not control what an application does after it deploys. A flow that passes all tests and deploys to production can still move data in ways the organization never intended. A flow that follows good ALM discipline can still connect to services that violate compliance policy. This is where connector governance becomes critical. Connectors are the integration layer. They determine what data flows where. A connector is a pre-built integration that Power Platform provides. Connect to SharePoint, connect to Salesforce, connect to a SQL database, connect to Dropbox, connect to any external API. The connector abstracts the integration complexity. A flow builder clicks on a connector, specifies what data to move. The connector handles the authentication, the API calls, the data transformation. The problem is architectural. Connectors are approved at the tenant level, not enforced at the application level. This is the distinction that matters. When an administrator approves a connector, that connector becomes available to every application in the environment, every flow, every Power App, every automation. There is no mechanism that says this connector is approved only for this specific application or this connector can only access this specific data source. The approval is binary. Either the connector is available everywhere or it is not available at all. Connector governance requires three-tier segmentation. Not all connectors are equally risky. Some connectors touch only internal services, some touch external services. Some should be blocked entirely. Tier 1 is low-risk connectors. SharePoint, Teams, Outlook, Dynamics, internal services that the organization controls. These connectors are approved by default. Users can use them without additional justification. They connect to systems the organization manages. The data is subject to organizational controls. Tier 2 is high-risk connectors. External storage services like Dropbox, Google Drive, personal OneDrive accounts, social media connectors, generic HTTP APIs. Connectors that move data outside the organization or to external services. These connectors require explicit approval. A flow that uses a high-risk connector must be reviewed before deployment. The review assesses whether the connector is being used appropriately, whether it is moving sensitive data, whether it violates compliance policy. Tier 3 is blocked connectors. Services that violate compliance requirements, services that violate data residency policies, services that the organization has determined should never be accessible from Power Platform. These connectors are not available, not in development, not in test, not in production. A blocked connector cannot be used regardless of business justification. The enforcement mechanism is data loss prevention policies. DLP in Power Platform can restrict connector combinations. You can create rules that prevent high-risk connectors from accessing sensitive data. You can enforce that high-risk connectors cannot be used in the same flow as business data connectors. You can mandate that certain connector combinations are not allowed. Third, the flows, thousands of them, were triggering automations across the entire technology estate. When a maker tries to create a flow that violates DLP policy, the platform blocks it. The flow cannot be saved. The flow cannot be deployed. The policy enforcement is technical, not advisory. DLP is not a recommendation. DLP is an architecture boundary. The real pattern that appears in enterprise audits is straightforward. Most organizations have no connector segmentation. All connectors are equally accessible. An administrator approves a connector. The connector is available to everyone. No tier, no restrictions, no enforcement against misuse. The consequence is that a single poorly configured flow can expose sensitive data. A developer with good intentions connects SharePoint to personal cloud storage. The data moves. The organization experiences a compliance breach. Connector governance requires mapping every connector the organization uses into the three-tier model, then enforcing through DLP which connectors can coexist. The enforcement prevents architectural misconfigurations before they reach production. But connector governance, like environment architecture and ALM pipelines, is enforced through infrastructure policy. It is not advisory. It is not optional. It is architectural. And architecture enforcement requires organizational discipline, ownership and lifecycle policies. Connector governance prevents inappropriate data flows. ALM pipelines enforce deployment discipline. Environment architecture separates development from production. These mechanisms control how applications behave. But they do not address a fundamental architectural problem. Who is responsible for the application after it exists? Power Platform allows applications to be created without clear ownership. A citizen developer builds an application. The application deploys. The developer becomes the owner by default. The ownership is implicit, not explicit. The application belongs to the person who built it. This creates a specific architectural failure. When that person leaves the organization, the application becomes orphaned. It still runs, it still accesses data, it still has security permissions, but nobody is responsible for maintaining it. Nobody is accountable for ensuring it continues to meet its business purpose. Nobody is tasked with retiring it if the business need no longer exists. Orphaned applications are technical debt in pure form. They consume resources, they create security surface, they require maintenance effort, they provide no measurable value, yet they persist because there is no mechanism that automatically retires them. Ownership enforcement solves this. Every application must have an explicit owner, not the person who built it. An accountable owner responsible for the application's lifecycle. For production applications, the owner is a service account, not a user, a service account. This distinction is critical. Service accounts do not leave the organization. Service accounts do not change roles. Service accounts remain stable. They own the application permanently. Individual developers can update the application. Individual developers can modify the logic, but the service account owns the asset. The service account ensures the application has a permanent steward. For development and team environments, individual makers can own applications. They are experimenting, they are learning, they are building shared solutions for their teams. Individual ownership is appropriate in lower-tier environments. But production applications require institutional ownership through service accounts. Lifecycle policy enforces accountability across the entire application portfolio. Every application has a documented purpose. What business problem does this application solve? Who uses it? What data does it access? These are not optional details. These are architectural requirements. An application without documented purpose is an orphan waiting to happen. Every application has success metrics. How do we know if this application is delivering value? Is usage growing or declining? Are users satisfied? Has the business problem it was supposed to solve actually been solved? Success metrics give the organization data to assess whether an application deserves continued investment or should be retired. Quarterly reviews make ownership meaningful. The owner of each application reviews the application. Is it still delivering value? Is the business purpose still relevant? Are there users? Are there security or compliance issues that need attention? The review is not a checkbox exercise. The review is the point where ownership becomes active rather than passive. Applications that show zero usage for 90 days enter a deprecation process. This is not immediate retirement. This is structured deprecation. First notification. The owner and stakeholders are notified that the application is showing no usage. They have the opportunity to justify why the application should continue. They can provide business context the metric does not capture. They can commit to reactivating the application. If no justification is provided, the application enters a remediation window. 30 days. The stakeholders have 1 month to demonstrate usage or provide documented business justification for keeping the application dormant. If the remediation window passes without justification, the application is retired. Not deleted, retired. It moves to a deactivated state. The application is no longer accessible. The connections are not active. The application is archived, not erased. Automatic retirement achieves what advisory governance cannot. It reduces the attack surface. Deactivated applications no longer consume security permissions. It lowers licensing costs. The organization is not paying for Dataverse capacity or connector licenses for inactive applications. It simplifies maintenance. The organization is not monitoring, patching, or supporting applications that deliver no value. The resistance to lifecycle management is predictable. Business stakeholders will argue that applications should not be retired. Applications might become useful again. Keeping dormant applications around preserves options. The cost of retirement is not justified by the benefit of potential future reactivation. This framing is backwards. The benefit of retirement is not reclaiming costs. The benefit is architectural clarity. Applications that do not deliver value should not persist. They should be retired. If a business need emerges later that resembles the old application, it is cheaper to rebuild with current architecture and current business understanding than to maintain a dormant application for years, hoping it becomes useful again. Frame retirement as freeing resources for innovation. Every application the organization retires is a resource freed for building something that delivers current business value. These 4 mechanisms, environment architecture, ALM pipelines, connector governance, ownership, and lifecycle policies, work together. They create a cohesive governance framework. Separately, each is insufficient. Together, they form sustainable power platform architecture. The center of excellence as architecture enforcer. These 4 mechanisms, environment architecture, ALM pipelines, connector governance, ownership, and lifecycle policies, require a function to enforce them. They require someone to own the architecture, someone to make decisions, someone to say no when necessary, someone to hold the line when political pressure mounts to circumvent the system. That function is the center of excellence. But the COE must operate differently than most organizations imagine. Most organizations treat the COE as an observability and advisory function. The COE publishes best practices. The COE maintains dashboards. The COE trains makers. The COE recommends governance patterns.
The COE is a resource center.
It advises, it guides, it educates. This approach fails systematically. Advisory governance is not governance. It is suggestion. For governance to work, the COE must shift from advisory to enforcement. The COE owns the environment architecture. The COE approves environment requests. The COE has veto power over new environments. If a business unit wants to create an environment, they request it through the COE. The COE assesses whether the request is justified, whether the proposed environment follows the tiered architecture, whether the business need cannot be met through existing environments. The COE approves or denies the request. This is not a recommendation. This is architectural authority. The COE owns connector policies. The COE determines which connectors are in Tier 1, which are Tier 2, which are Tier 3. The COE reviews connector requests. Can we approve this connector? Does it create compliance risk? Does it violate data residency? The COE makes the decision. Connectors are approved or blocked based on architectural assessment, not stakeholder pressure. The COE owns LM pipelines. The COE maintains the pipeline infrastructure. The COE ensures that production deployments go through the pipeline. The COE enforces that exceptions to the pipeline are rare and documented. If a business unit wants to bypass the pipeline for a production deployment, they do not bypass it. They request an exception to the COE. The COE assesses whether the exception is justified. The COE approves or denies. The exception does not happen without explicit COE authorization and documentation. The COE owns lifecycle enforcement. The COE monitors application usage. The COE executes deprecation for applications showing no usage. The COE does not ask permission to retire zombie applications. The COE executes the policy. Applications with zero usage for 90 days are deprecated according to policy. The policy is enforcement, not suggestion. The shift from advisory to enforcement requires resources. The COE cannot be a part-time responsibility. A Power Platform admin working 15% of their time on governance will advise but not enforce. Enforcement requires dedicated capacity. Organizations that succeed have a full-time platform owner, a full-time security lead responsible for connector governance and DLP policy, a full-time architect responsible for environment strategy and ALM pipeline maintenance. These are not secondary responsibilities, these are core functions. The COE also requires authority structure. The platform owner must have veto power, not influence, not recommendation authority. Veto power. The COE must be able to say no to environment requests that violate architecture, must be able to deny connector approvals, must be able to enforce retirement policies without requiring stakeholder consensus. This authority creates tension. Business units resist. They want flexibility. They want to build what they want when they want it. Architectural enforcement limits that flexibility. The COE becomes the boundary that prevents architectural chaos. Organizations with well-resourced COEs that have genuine enforcement authority achieve 3 to 4 times better outcomes in security, compliance, and operational efficiency compared to organizations with advisory COEs. This is not theoretical. This is observed pattern across enterprise tenants. The trade-off is political. Giving the COE enforcement authority means the business units no longer have complete autonomy, means requests get denied, means policies are enforced even when inconvenient. This requires executive sponsorship. The CTO or the CIO must visibly champion the COE as a strategic function, must back the COE's authority when business units complain that governance is slowing them down, must frame governance enforcement as enabling responsible innovation, not restricting it. Without that executive alignment, the COE collapses. Without authority, the COE becomes advisory. Without advisory governance, architecture fails. The organizations that succeed treat the COE as the control plane, the authority structure that ensures Power Platform operates as a managed platform, not an uncontrolled development environment. The cultural and organizational requirements. Architecture governance requires organizational alignment. This is not technical. This is structural. You cannot enforce environment strategy if security and IT disagree on connector policy. You cannot enforce ALM pipelines if the business units believe governance is IT overhead. You cannot enforce lifecycle management if the stakeholders who own the applications resist retirement. Alignment requires a governance council, not a committee, not an advisory board. A council with genuine authority. Cross-functional representation from IT, security, compliance, and business. Each function brings a different lens. IT brings operational perspective. Security brings risk perspective. Compliance brings regulatory perspective. Business brings value perspective. The council synthesizes these perspectives into binding decisions.
The platform owner represents IT.
Responsible for environment architecture, ALM pipelines, and operational health. The security lead represents security and compliance, responsible for connector governance, DLP policy, and security enforcement. The business sponsor represents the business units, responsible for ensuring governance enables rather than blocks value delivery. Each role has equal authority. Each role has veto power. Decisions require consensus or escalation. The governance council establishes decision frameworks. Clear criteria for which applications can be built. What types of problems is Power Platform intended to solve? What problems should be solved through traditional development instead? Criteria for which connectors are approved, which connectors create acceptable risk, which data can be combined with which connectors. Criteria for environment requests, what business justification is required, what is the approval threshold. These frameworks are not secret, they are published, transparent. Every maker in the organization knows the criteria. Everyone knows what gets approved and why. Everyone knows what gets denied and why. This transparency prevents the perception that governance decisions are arbitrary or political. Resistance management is unavoidable. Business units will resist governance. They will argue that approval processes slow them down, that architectural restrictions prevent them from building what they need, that the COE is bureaucracy. This resistance is not malicious. It is structural. People naturally resist friction, naturally prefer the path of least resistance. The response is not to remove the friction. The friction is the point. The response is to reframe the friction. Governance is not restriction. Governance is enablement. Governance enables responsible innovation at scale. Governance prevents technical debt. Governance prevents security failures. Governance prevents compliance breaches. Governance enables the organization to build fast without breaking things. This reframing requires executive sponsorship. The CTO or the CIO must visibly champion governance, must communicate to the organization that Power Platform governance is a strategic priority, must back the COE's decisions when business units complain, must frame governance as essential, not optional. Without executive sponsorship, governance collapses. When the CTO remains silent on governance decisions, business units interpret that silence as indifference. They escalate, they go around the COE, they request exceptions. The governance structure erodes. With executive sponsorship, governance holds. When the CTO says governance is how we operate Power Platform responsibly, the organization hears that message. Governance becomes the expected operating model. Violations become exceptions requiring escalation, not acceptable workarounds. Real pattern across enterprises. Organizations without executive alignment treat governance as an IT checkbox, something IT does, something to document for compliance, something that is optional when business pressure mounts. These organizations implement all the mechanisms we have described: environment architecture, ALM pipelines, connector governance, lifecycle policies, but none of them are enforced. They exist in documentation and dashboards. They do not exist in infrastructure. Organizations with executive alignment treat governance as a platform requirement, something that is built into how Power Platform operates, something that cannot be bypassed, something that everyone understands is non-negotiable. The difference in outcomes is profound. Organizations with executive alignment report significantly better security posture, lower sprawl, lower technical debt accumulation, and lower unplanned maintenance burden. Cultural change is slow. This is not a 3-month implementation. This is sustained organizational shift. It requires repeated communication, repeated reinforcement, repeated demonstration that governance is the expected operating model. But cultural change is the only path to sustainable Power Platform architecture. Architecture without cultural alignment is merely policy. Policy without cultural alignment is never enforced, and unenforced policy is not governance. Sustainable technical practices, architecture and governance create the framework. They establish the boundaries, they enforce the rules. But within that framework, individual applications still need to be built with discipline. Sustainable technical practices are how you operationalize governance, how you make the rules actually prevent the problems they are designed to prevent. Documentation standards are the first practice. Every application must have documented business justification, not a summary, a documented statement of why this application exists. What business problem does it solve? Who are the users? What is the success metric? This documentation is not optional ceremony. This documentation is how the organization later assesses whether the application is still delivering value. Without documented purpose, the organization cannot tell the difference between an essential application and a zombie waiting for retirement. Every production application must have technical architecture documentation, not implementation details. Architecture: how is the data structured? What are the integration points? What external systems does this application depend on? What dependencies do other systems have on this application? This architecture documentation is how the organization understands the relationships between applications, how it assesses the impact of changes, how it prevents fragile cascades of dependencies. Data flow diagrams are mandatory. Where does data come from? What transformations happen? Where does data go? This is not a flowchart. This is a clear diagram showing every place data touches, every connector, every external system, every storage location. When the organization later discovers a compliance issue, the data flow diagram is what identifies where the issue originated and what it impacted. Code review discipline replaces the assumption that citizen developers automatically produce maintainable solutions. It does not. Code review is how you catch architectural mistakes before they reach production. A solution architect reviews every production application before deployment. The review is not checking boxes. The review is assessing whether the application follows architectural patterns, whether it is designed for maintainability, whether it makes reasonable design decisions, whether it avoids unnecessary complexity. This creates friction. Citizen developers want to deploy. The code review adds delay. The code review can result in rejection. The solution architect can say, rebuild this. The architecture does not work. And this is the point. Not all applications are ready for production on first attempt. Better to catch architectural problems before deployment than after the application becomes critical and unmaintainable. Testing requirements move beyond, it works on my screen, to structured validation. Functional testing confirms the application does what it is supposed to do. Security review assesses whether the application creates security vulnerabilities. Connector security, data access patterns, authentication mechanisms. Performance testing confirms the application scales. Does the application degrade when users increase?
Do queries run within acceptable time?
Does the integration handle load? These requirements add process. They slow deployment. They are supposed to. Production deployment should not be instant. Production deployment should be validated. Monitoring and alerting are the ongoing practices. Production applications are instrumented, failures are detected, performance degradation is captured, anomalous behavior triggers alerts. This monitoring is not passive observation, this is active management. When a flow fails more than expected, an alert fires. When a query response time degrades, an alert fires. Someone responsible for the application is notified, someone investigates, someone either fixes the issue or escalates it. Incident management establishes clear escalation paths. When something goes wrong in production, the responsible party is notified immediately, not hours later, not after users report the problem. Immediately. The incident is documented, the impact is assessed, the organization mobilizes to fix it. After the incident is resolved, a post-incident review examines what failed, what could have prevented it, what process should change to prevent recurrence. Refactoring discipline treats technical debt as an ongoing liability rather than something to address during crisis. Organizations allocate capacity, 15 to 20% of development effort, for refactoring, for addressing technical debt incrementally, for improving maintainability, for modernizing aging applications. This allocation happens continuously. It does not wait until the application becomes unmaintainable. Reusability patterns accelerate this process. Common patterns are packaged as templates. Common integrations are packaged as components. Instead of every application reinventing the same solutions, teams build on established patterns. This reduces duplication. This accelerates development. This creates consistency across the application portfolio. Organizations that implement these practices systematically report maintenance cost reductions of 20 to 50%. This is not theoretical. This is observed pattern. Applications built with discipline cost less to maintain. Applications that undergo consistent refactoring accumulate less debt. Applications that follow established patterns scale more reliably. These practices, combined with architecture and governance, create sustainable power platform operation. Not frictionless, not instant, responsible. What sustainable power platform architecture actually looks like. Sustainable power platform architecture is not governance as restriction. Governance as restriction is what most organizations implement. It is rules designed to prevent people from doing what they want to do. It is bureaucracy. It is friction. It creates resentment. Sustainable architecture is governance as enablement. It is a framework that makes responsible innovation faster than irresponsible innovation. It is rules designed to prevent certain kinds of failure. It removes the uncertainty and friction that comes from unmanaged platforms. It accelerates the path to production for applications that follow the rules. Here's what the model actually looks like when implemented. Environment architecture is tiered. Default environment is locked down. Personal experimentation only. No production data, no business critical connectors. Makers can experiment, can learn the platform, can build personal automations. They cannot accidentally move sensitive data to external services. The platform architecture prevents it. The default environment is restricted. Tier 2 environments are for team solutions. Clear business justification required. Approval process. Once approved, the environment is created with defined governance rules. Teams can build shared applications. Multiple makers can collaborate. The environment allows standard connectors. Tier 3 is enterprise production. Restricted access, formal architecture review required, security assessment required, managed solutions mandatory, deployment through pipelines mandatory, service account ownership mandatory. The platform enforces these requirements at the infrastructure level. Tier 1 makers cannot create applications in Tier 3. Tier 2 teams cannot bypass the pipeline. Connector governance is 3-tier. Low-risk connectors, SharePoint, Teams, Outlook are available in all environments. High-risk connectors, external storage, social media, generic HTTP APIs, require explicit approval.
Blocked connectors are not available anywhere.
DLP policies enforce the segmentation at creation time. A maker tries to create a flow that violates DLP policy. The platform blocks it. The flow cannot be saved. The violation is prevented, not detected after the fact. ALM pipelines are mandatory for production. Applications move through development, testing, production through automated pipelines. The pipeline runs automated tests. The pipeline enforces security scanning. The pipeline requires approval gates. The pipeline is not optional. There is no alternative path, no manual imports, no direct production deployments. The pipeline is the only way to reach production. This creates a 2-week deployment cycle instead of instant deployment. This is intentional. Instant deployment to production is not responsible engineering. Tested, reviewed, tracked deployment is. Ownership enforcement is clear. Production applications are owned by service accounts, not users, service accounts. This ensures continuity. When the developer leaves, the service account remains. The application has a permanent steward. Quarterly reviews assess whether applications are delivering value. Applications showing 0 usage for 90 days are deprecated, not kept as orphans, actually retired. The organization stops paying for infrastructure, stops maintaining connections, stops managing security permissions, stops managing applications that deliver no value. The center of excellence is not advisory. The QE has authority. Environment requests go through the COE. The COE approves or denies based on architecture. Connector requests go through the COE. The COE determines Tier 1, Tier 2, Tier 3. LM pipeline exceptions go through the COE. The COE documents and approves. The COE owns the architecture. The COE enforces it. Measurement is continuous. Dashboards track adoption, track cost, track app portfolio health, track technical debt accumulation, track success metrics. The organization knows what is running, knows what is delivering value, knows what is consuming resources without delivering benefit. This measurement informs decisions. This measurement makes lifecycle management possible. Real outcome is what differentiates sustainable from aspirational. Organizations that implement this architecture report faster innovation, not slower. Report lower costs, not higher. Report better compliance, not worse. This seems paradoxical. More governance should slow innovation. More rules should increase cost. More restrictions should reduce compliance violations. But here's what actually happens. Governance removes the chaos that slows innovation, removes the rework that increases cost, removes the unmanaged sprawl that creates compliance violations. A developer in a well-governed organization knows what the rules are, knows what gets approved, can iterate rapidly within defined boundaries, knows that once they reach production, their application will be maintained, will be monitored, will be supported. Innovation accelerates because the uncertainty is gone. A developer in an unmanaged organization faces constant friction from unexpected production failures, friction from unsustainable technical debt, friction from unclear ownership, friction from applications that become unmaintainable. This friction slows innovation. This friction increases cost. This friction creates compliance violations because people bypass governance to avoid the friction. Sustainable architecture removes that friction by making governance fast and automated. Environment requests are processed in days, not weeks. ALM pipelines are automated. Connector governance is enforced by the platform, not by manual review. Lifecycle management is automatic. The organization does not ask permission to retire zombie applications. The organization executes the policy.
The rules are clear.
The enforcement is fast. The path to compliance is efficient. This is the architecture that succeeds. The mindset shift required. The entire framework we have described, environment architecture, ALM pipelines, connector governance, lifecycle policies, centers of excellence, all of it depends on a single prerequisite. A fundamental mindset shift about what Power Platform is. The old narrative is, low-code means less governance. This narrative is seductive. Low-code platforms are marketed on speed, on accessibility, on democratization. The narrative says that low-code removes the IT backlog by enabling non-technical users to build applications without needing developers, removes the friction of traditional software development, removes the overhead of formal processes. Low-code means fast. Low-code means simple. Low-code means less governance. This narrative is wrong. The new reality is, low-code means distributed governance. Power Platform is not replacing software engineering. It is distributing software engineering across the organization. Every citizen developer who builds an application in Power Platform is performing software engineering work. They are architecting data models. They are building business logic. They are integrating systems. They are making security decisions. They are handling sensitive information. They are performing functions that have traditionally been the domain of professional software engineers. The governance did not disappear. The governance became distributed. The organization went from one team of developers implementing one governance model to hundreds of makers implementing governance or not implementing governance independently. The complexity of governance increased exponentially. The organization now needs governance discipline not just in IT, governance discipline across the entire platform, across every maker, across every application. This is the uncomfortable truth that most organizations avoid. Citizen developers are software engineers. They have different skill levels. They have different backgrounds. They have different training. But they are performing software engineering work. The organization that enables them without applying software engineering discipline to their work is enabling architectural failure. Here is what this actually requires. It requires training. Not here is how to click buttons in Power Apps training, real training, training in data modeling, training in integration architecture, training in security principles, training in performance optimization, training in documentation discipline, training that transforms citizen developers into competent software engineers. It requires accountability, not "you are responsible for your application" accountability. Real accountability, performance reviews that assess whether applications meet architectural standards, career progression that rewards engineers who follow discipline and penalizes those who do not. Accountability that makes clear that building without discipline is not acceptable. It requires architecture discipline, not "here are some guidelines." Real discipline, standards that are enforced, patterns that are mandatory, approaches that are required, alternatives that are blocked, discipline that makes following the rules easier than breaking them. It requires governance enforcement, not advisory governance. Real enforcement, environment restrictions that cannot be bypassed, Elm pipelines that are mandatory, connector policies that are technical boundaries, lifecycle policies that automatically execute, governance that is built into the infrastructure. The benefit of making this shift is real. Organizations that treat Power Platform as a development platform that requires development discipline unlock genuine productivity gains. They build faster, they build more reliably, they build with lower technical debt. They operate with lower risk. They accumulate less sprawl. They achieve sustainable growth. The risk of not making this shift is equally real. Organizations that pretend low code means less governance end up with everything we have described: sprawl, debt, security exposure, compliance violations, escalating costs, unmanageable complexity. They end up with uncontrolled development platforms masquerading as productivity tools. Real observation from enterprise audits. The difference between successful and unsuccessful Power Platform implementations is not tooling. Both successful and unsuccessful organizations use the same platform. They have access to the same features. They have access to the same governance tools. The difference is mindset. Successful organizations understand that Power Platform is a development platform. They apply development discipline. They enforce architecture. They measure outcomes. They retire applications that do not deliver value. They invest in the governance infrastructure required to operate at scale. Unsuccessful organizations understand that Power Platform is a productivity tool. They enable it. They encourage use. They avoid bureaucracy. They treat governance as optional. They accumulate debt and sprawl. They eventually face crisis and attempt remediation. The mindset shift is the prerequisite for everything else. Without it, governance is theatrical. Infrastructure exists but is not enforced. Rules are published but are not maintained. Architecture is designed but is not implemented. With it, everything becomes possible. Governance is enforced. Infrastructure enables compliance. Rules are maintained. Architecture is sustainable. This mindset shift is not technical. It is cultural. It requires executive sponsorship. It requires sustained communication. It requires visible commitment that Power Platform is a platform, not a toy. That governance is how the organization operates, not an optional layer. The organizations that make this shift early gain competitive advantages. They scale faster. They operate with more confidence. They unlock real value from low-code platforms without drowning in debt. Immediate governance checklist. Start with default environment lockdown. Restrict connectors. Disable production apps. Create 3-tier environments: personal, team, enterprise. Implement DLP policies and ALM pipelines. Enforce service account ownership. Retire unused apps after 90 days of zero usage. Establish a center of excellence with genuine authority. Track adoption and cost. Timeline: 12 weeks. Executive risk summary. For IT leadership, the Power Platform problem is not fundamentally a citizen developer initiative problem. Citizen developers are symptoms, not causes. The problem is a platform governance problem. You have deployed a development platform without development discipline. You are operating that platform without architecture enforcement. You are pretending governance is optional because the platform is popular and adoption is strong. Reframe this in your mind. Power Platform is not a productivity tool. It is not an alternative to spreadsheets. It is a distributed development environment embedded inside Microsoft 365. Treat it accordingly. The risk categories are concrete. Architecture sprawl is the first category. Unmanaged app proliferation creates visibility gaps. It creates operational complexity. It creates dependencies you cannot see. An application in the default environment depends on a connector. That connector depends on a service account. That service account gets deprovisioned. The application fails silently. Nobody knows it failed for weeks. The ripple effects cascade. This is architecture sprawl creating operational risk. Security exposure is the second category. Overly permissive connectors move sensitive data outside the organization. Missing DLP segmentation allows risky connector combinations. Orphaned applications retain security permissions for accounts that no longer exist. Zombie flows continue running against business-critical data nobody is monitoring. Each of these creates an attack surface. Each expands the pathways an attacker can exploit. Each increases the likelihood of a breach. Hidden operational costs are the third category. Licensing surprises emerge when Dataverse storage explodes. Premium connector usage skyrockets. Environment sprawl requires additional licensing tiers. The organization suddenly discovers Power Platform is a top 5 SaaS cost. But the organization cannot determine which applications justify the cost. It cannot determine which are abandoned. The cost is real, but the value is invisible. This is operational cost without operational insight. Compliance issues are the fourth category. Unmanaged data flows violate compliance requirements. Missing audit trails prevent demonstrating regulatory compliance. Orphaned applications break compliance controls. Shadow IT in a Power Platform creates the same risks Shadow IT in unapproved SaaS tools creates. Regulatory bodies do not distinguish between governance failure in Power Platform and governance failure in other systems. A compliance breach is a compliance breach. A data exposure is a data exposure. The quantified risk is stark. Organizations without formal Power Platform governance face 3 to 4 times higher rates of security violations and compliance breaches. Not statistically higher, not marginally higher, 3 to 4 times. This is not a minor risk. This is a material risk to the organization. The business case for governance is straightforward. The organization can invest in architecture and governance now. The organization can implement environment segmentation. The organization can enforce ALM pipelines. The organization can establish a center of excellence with genuine authority. This investment prevents exponentially larger costs in remediation and technical debt later. Or the organization can defer governance. The organization can continue enabling Power Platform without discipline. The organization can continue accumulating sprawl, debt, and compliance exposure. The organization can continue until crisis forces remediation. At that point, the cost is orders of magnitude higher. The remediation is organizational disruption. The recovery is measured in years, not months. Real pattern from enterprise audits. Organizations that address Power Platform governance proactively report better security outcomes, lower compliance violation rates, and lower total cost of ownership than organizations that attempt retroactive remediation. Not slightly better outcomes, significantly better. The investment in governance early prevents the crisis later. For the executive making decisions about Power Platform governance, the question is not whether governance is worth the investment. The question is whether the organization can afford not to invest, whether the organization can sustain the risk of operating a distributed development platform without development discipline, whether the organization can accept the compliance and security exposure, whether the organization can absorb the escalating costs. The answer across every enterprise that has assessed this is no. The organization cannot afford not to invest in governance. The organization cannot afford to operate Power Platform without architecture discipline. The central thesis: Power Platform is not the problem. The problem is pretending it isn't a real development platform. Organizations that treat it as a toy end up with low-code debt, sprawl, security exposure, and escalating costs. Organizations that treat it as a platform with architecture discipline, governance enforcement, and ownership accountability unlock real productivity and sustainable growth. The choice is clear: invest in governance now or pay for sprawl later. Subscribe to M365FM for more deep dives into Microsoft ecosystem architecture and strategy. If this episode resonated, please leave a review on your podcast platform. It helps us reach more IT leaders and architects. Connect with me on LinkedIn and let me know, what Power Platform governance challenges are you facing in your organization? Your feedback shapes the next episodes.